I was hoping there would be a lot of people here when I saw Rob Rich's talk. Was it yesterday on Git? And he had a full room, so I was hoping we had a lot of coders, and hopefully most of you are. But Bash is not only good for coders and DevOps people, it's good for anyone with a computer. But it does have a quirky syntax, and it takes some getting used to. But if you give it some time and don't worry too much about it, then I think Bash is for you. So, DevOps engineers. It's kind of engineer, you start thinking about people who have very precise instruments and get stuff working by measuring, planning, and doing everything like that. DevOps engineers, that's a different thing. DevOps is more like this. You get stuff working by gluing a lot of things together. And Bash, I'm going to argue now, is that's one of the best tools to do this. And as you can see on this code, it's full of quirkiness, and it may be hard to understand if you're used to a more structured programming language, like Java, Go, C#. Even JavaScript may look clean compared to Bash. But if you just get over the quirks and get on with it, it's fantastic. And it's everywhere. It's on code build, it's in GitHub Actions, it's on GitLab. Anything you can think of, there's a Bash available. And as soon as you can run a container there, obviously you can run Bash. And I'm going to come with some propositions here that you get kind of on the way, since it's an ugly language. It doesn't really matter that much how your code looks, because it already looks ugly. So, and you're not writing a server. It's not going to run forever. It's going to run for maybe 30 seconds or maybe 5 minutes. And then if it crashes, you probably just run it again. Or you have a pipeline that will run it again. So I'm going to suggest that you just make it work, clean it up a little bit. You should be able to understand your own code. But sometimes it's so quirky, you may not do that. And then there's actually a call for having comments. But then once you have it working, and it's working on your local machine, then you move it to the CI server, and hopefully it will just work there. Especially if you've been running it on a container on your local machine, it should work. And then you just move on, and don't worry about it anymore. You don't need to clean it up. You don't need to make this the most beautiful code in the world. And it's also okay to just Google. Stack Overflow is full of one-liners for Bash. And just Google, copy, paste, and then I would suggest that you learn what you're writing. But that's for your own sake. It's not because the script will just run anyway. It doesn't care if it looks ugly and you don't understand it, as long as it does what it's supposed to. But for your own sake, next time you want to write something, then you know how to do it and you don't have to Google for it. And also, don't write code in YAML or any other of these build files. Just write it in a script and then only pass the things that you need to from the build workflow file or whatever. So, the way I'm going to do this is I'm going to show you a bunch of small scripts, and then I'm going to explain things about them, and then I'm going to show you some takeaways from this specific script. And we're starting out with really easy stuff, but I'm planning to move fast and get on to more interesting stuff later. So, And if you have any questions, just fire away, and it's probably better if I answer it right away. Otherwise, we may have time for some questions afterwards. All right, so here we have a script called just first.sh. It has a hash bang at the start. It's using bin bash. You can write this in many different ways, but as long as it works, you can use bin bash, user bin bash, user bin n, space bash. It doesn't really matter, as long as you get it working. And the first line here is grepping for something. It's grepping for C, but it doesn't take any input. So that means that this script, first.sh, will wait for input for this first command. After it has gotten some input, it will move on and write the two different echoes, standard out and to standard error. And output for standard error is really quirky. It means redirect standard out, because echo writes to standard out, to standard error. Oh, yeah, that's why I put the big marker here so I can point. So here is an example when this is run. You just run it like this if it's in your current directory. And in this case, the first case here, it will just hang because it will wait for standard input. And then you have to enter that on the keyboard. But in the second line here, it outputs whatever in dogs.txt, and then it pipes it on to this script, which means the standard input of first.sh will be the standard output of cat or dogs.txt. And the third line, then I just pipe or redirect the standard output to dev.null because I don't care about it. So if this is run, here's first the input of dogs, or the contents of dogs.txt. When I pipe it to first.sh, it's going to get the first grep C and get the two dogs that starts with a capital C. Then it's going to print to standard out and to standard error. And in the case where I redirect standard output to dev null, all I get is standard error. So that's the first basic script. And every script has a standard in, a standard out, and a standard error. It also has an exit status, and the exit status is 0 for successful runs. That will probably get you if you're used to C programming, where it's anything but 0. The first command that reads standard input will hang until it gets standard input. And the exit status can be used in conditionals to test. So if a command succeeds, then I can do this. And if it fails, I can do something else. And you can also capture standard out. So that's a way to handle outputs that's not just a number. All right, second script. So in almost all scripts, you want to have this line, set-o error exit. It means that if a command fails, it will exit the script at that point in time. If I didn't have this line here, it would just run every command, and even if it failed, it would continue to run the rest of the commands. Line 5 prints the program name, that's $0. Then the arguments come from 1 through 9. And environment variables can be read just as if they were on the command line. You could also pass environment variables on the command lines, which I'll show you down here. So if I invoke the command CLI equals cool.simplest8sh with 3 arguments, yeah, I can show you. The output would be this. So in my case, the user is Jan9. The environment variable here from the command line, the CLI, is cool. And then all the arguments is $@. You can loop over them. And then I try to do an ls command with a missing directory. And after that, there's an error, and this line 19 won't execute because of this set error exit here. And if it wouldn't have been there, it would have continued and run that line too. And that way to pass variables into on the command line like this, CLI equals cool, space, and then my next argument, is a perfect way to pass arguments and options into a script, especially if you're running it in a DevOps pipeline where you usually don't have the possibility to pass arguments in a different way. It's just easy. You can just set environment variables, and they will be picked up by the shell or the script. So the takeaways here are every line executes a command. Set error exit, always. Then you should always quote your arguments. There are exceptions, but always is a good first choice. If you're using single quotes instead, you won't get variable expansion. So here docs. This is a way to get standard input from the current files. So in this case, I set an extra option here, pipe fail, because I have a pipe down here. And if you don't set pipe fail, then it will continue to run the commands in the pipeline until the last command. So if the first part of the pipeline fails and the last command succeeds, it will still think it's a success. So as soon as you use pipes, add the pipe fail option. Here we have declare a variable, and here is the here document. And this dollar parenthesis here tells bash that I want to capture the output from this command. And in this case, it's the here document, and it will read all the text down to EOT on a single line, so down here on 13. So what I have after this cat command has run here is that inside my string I have this JSON blob here, which will contain the value of avar, and also that I execute the command ls, so the code would have the value of every file in the current directory. And then the last thing down here where I pipe it into JQ. JQ will format, and you can do a lot of stuff with JSON. It stands for JSON query. But in this case, I only use it to validate that the JSON that I have just created is valid. And if it wouldn't have been valid, then it would have exited. So it's to prevent having typos in your code. So takeaways here, always use pipe fail if you have pipes. Variable expansion is done inside double quotes, and you also command expansion. And you can also nest command expansions inside each other if you have the need for that. The here docs doesn't have to end with EOT. It can be whatever, but then that line has to be on a line by itself to capture everything up to that line. And this is great for generating basically any structured text or anything, especially JSON. So here's another script where I'm caching some output. So in this case, this command, the curl command down here, needs to have a token. And that token takes a pretty long time to generate, so I don't want to generate this token every time. So in this case, the first interesting part here is because the token file here, just the name, I check if it exists, And if it doesn't exist, I'll set the age, or if it does exist, sorry, I set the age to whatever time the file is. And I'll come back to how it works. And it has been initialized to 100 because I want to compare, if there is no file, I want it to create the file. So then I check here, and you can see in this if statement here, before I used 2 square brackets. In this case, I'm doing arithmetic, so I want to have parentheses instead. So I do this comparison. Is it older? Then I refresh my token and put it into this file. And then I use it later down here in the curl command. And in this case here, I'll get the age through the date time right now in seconds. I subtract that from how old the file is, and then, or from when the file was actually modified. And then I divide this by 60 because this time here is in minutes and not in seconds. Yeah, and sorry? I can't hear you. In this case, it's safe. So yeah, I don't always follow my own advice. But in this case, it's safe. So, but if it would have been input, it wouldn't have been safe because then it would have been 2 variables here, and it probably could have been spaces in it, and then it wouldn't have worked. And also, you don't really need much precision. So in this line here, line 20, I just cat the token file. The token file may contain so much stuff, but I grab for the line that contains Akamai, and that's exactly the line that I want to put into my curl command later, so I don't care about the rest. And if there would have been 2 Akamai things in this token file, then it wouldn't have worked. But it doesn't really matter, because I know in this case there won't be more than 1, so I don't have to worry about it. And in this case, caching is good for not having to invoke this slow command every time. But it can also be good for integration testing if you run a curl command, and if you're developing something, you call an API many times, and you don't want to overload the API because you may not be allowed to call it too many times. Then you can just cache it into a file, and then you measure how long you want it to be cached, and then you just regenerate or rerun the command after. So, takeaways for this. So the conditionals, you either use double square brackets, and inside there you can put a lot of weird options which you probably have to look up. But most of the time you check for a file or you check for a directory, and that's -F and -D. There are a bunch of other options for symbolic links and if it's executable, and you can check basically anything. But if you're checking numbers, it's better to use double parentheses. And also when you do arithmetic here, you can do that by invoking with $, and 2 parentheses, and then you can do simple arithmetic for calculating stuff. And pipes went through before. And, yep, sure. Because it's doing arithmetic, if I only do $1 parenthesis, then it invokes a command instead. But in this case, if you do put 2 parentheses, it will do arithmetic. Just one of the quirks of Bash. All right, and this does basically the same thing as before, but it's just to show that you can write functions in Bash, and and there's a lot of extra file checking here. I check if the file exist, which I don't really have to because I know it's invoked down here. So I know for sure that it does exist. So, but if you're writing something that someone else may be using, maybe you should put in some checking. But the syntax here is pretty neat. So if you do dollar curly bracket and then the name of the variable, or in this case it's the first argument, and then a question mark after that, then it will check if this file is there. And then whatever is printed, if it's not sent in, not passed in, it will just exit. So it's a nice way to check for required variables. And other than that, it's nothing really special. You just type a name, 2 parentheses. You don't have the arguments in there. They will be $1, $2, just as if you invoked a script. In fact, you can think of functions as if they are a script. So they will have standard in, standard out, standard error, and an exit status. So you can put a bunch of function in a pipeline. It's just like a local script within the file. Here is also an example of where I use a single bracket, and a single bracket that was used before Bash came into the world. So if you use the old script called born shell, Bash stands for born again shell, so it's the next version of born shell, then you should probably use 2 square brackets, just because you have better options. It's a built-in into the language, while this is actually a command. This is exactly the same as the test command that you can write on the command line. All right. So functions. You can declare local variables inside a function by just putting the local keyword before it. Variables can be checked in different ways. You can check with a question mark for if it's required or not, and it will exit if it's not set. And here are 2 ways to, in this case, the file has a name, so the error output will be better in this case. You will get file is required as output. But in this case, it's a number, so it will say 1 is required, which doesn't really tell you much. So it may be a good idea to actually put in what you were expecting to get there. But it will still print a little quirky 1 file is required. And the third there is if you have default values, you just do a : dash, and then you can put any default values there. So that's for options, and question mark is for required variables. And here you see the 2 different ways also to call a function. So in the first case, I use the exit status as my return value, but in the second call, I use the output. So in the case of this local function, this out here would be out, and out ABC would be the value inside out. Inside out, funny. All right. So here's another script, and this is another neat trick. If you do this, you test if trace is set. So trace could just be passed on the command line, like I showed you before, trace equals anything. And then we set X here. And X means that before every command is run, it will be printed to standard out. So it's a nice way to debug Bash files if they fail. Echo error is a function that just simplifies, so you don't have to write this quirky syntax every time. So every time you want to write something to standard error, you can just use this echo error. Check again here. I use because I'm lazy. But I should have used double brackets here, but in this case it doesn't work because it still uses, or it doesn't matter because it still uses an old not equals option that was from Bourne shell. And it checks if there's an argument passed. So this is the number of arguments, what's that called, hash. And in case it's not, it writes the standard output and exits, or standard error and exits. Then the new version here, so if a version is passed in with a V in front of it, because that's how we do our tagging, we name them V1.2.3 or something. But I don't want that, I don't want the V. So I strip off all V's in case many V's are passed. So new version in this case would be 1.2.3. Then I grep for this value here inside my release node. So I want to check that my release nodes has this version described before I actually create the release. And so it will grep for that version. If it's not there, it will exit again. And then we come down here to this beauty. And here's actually a comment, because it's, even if I wrote it, I still have a hard time understanding what it does. But it checks for $version, and version is the new version up here. Or, sorry, not dollar, hash version, because that's how our release notes look. And if it finds this value, it will set the flag to 1. And then it will skip to the next line. This is AWK. And then it will skip on to this flag value here. And this value will be 1 the next time we come around. And if it's 1, the line will just be output standard out. So it will continue printing every line from the new version, and then it will, next time there's a hash at the start of a line, it will set the flag back to 0. And nothing else from the release notes would be printed. And so inside my description there, I would have the exact description that I have in my release notes. And then I can use that with whatever. We'll come back to the rest of the script. So if I want to print commands before executing, I use this. You can just do set X if you want to do it every time, which is fine. But I usually only want to do it while I'm debugging. Echo the standard error, this little magic here. Trim all these from the left. If I want to trim the tail or the end of the string, I use percentage instead. And percentage would trim as little as possible, but if I double it up, it will trim as much as possible. And then you can also check for the exit status of commands. So grep and most commands, you will see Git, most good command line tools will exit with an error exit status when they fail. So it's really good to use that when scripting. So in this case, I check if there is an error. If I can't find the version within this file, then I'll do something. And here's the AWK. And AWK stands for Aho, Weinberg, and Kernighan. I don't know, Kernighan you should probably recognize. He's the one who built the C language and was also involved with the Unix operating system. So these are really old and talented guys. So, and they released a new version of this just a little while ago with support for Unicode. It's a fantastic command where you can just run a lot of code for every line. So I recommend looking it up. All right, so continue. Now we have description as a variable. So I want to, here I do this check again here. I want to check if there is something, yep, sorry. Yep. You can set it inside the script, like just set -x at the top of the script. No, I don't think it will take actually. So you can, but you can put it on the hash bang line also. If you do user bin bash -x, you can put it there. But if you set it on the command line, I think it will be running in a subshell and it won't come up. All right, so this is just to demonstrate how good Git is. That Git commands will always do what you expect them to do. And in this case, it will, if there's a diff, it will return an exit status that will tell me there's something changed in my directory, and I don't want to release it because then maybe my tests were working, even though this is not what I'm releasing. Yeah, these are just checks. So, and then there's sed, which is also a nice command. It stands for stream editing, and you can use it for doing find, replace, deleting lines, anything you can do basically with find, replace in an editor, you can do with sed on the command line. So in this case, I just replace whatever the old version was in these 3 files, version go, targets.json, and package.json, with the new version that was passed on the argument. And then, remove, sed creates backup files, and I just remove them because I'm not interested in them. And then here, the git commit command actually takes, you can pass -m multiple times for the message, and the first m you pass will be the subject line, and then it will make an extra line, and then the rest will be the rest of the commit message. And in this case, I stick the description into that. And tag and push. And don't even have to check those errors, because if the errors would have been there, they would have failed because of the error exit at the beginning of the file. So Git return values are awesome. You can pass multiple messages to Git, and sed is awesome for modifying files or lines inside a file. If you need to do some cleanup, you can trap signals. So and the way you do trap signals is you just declare trap, and then whatever function you want to call. And then, in this case, I'm interested in the exit trap, which will execute every time the script exits, even if it fails or not. So in this case, it will remove this template. And you can catch other signals. Exit is the most common one, but you can also, if you have scripts that are running a little longer, you may want to catch sigint and sigquit. But I would probably argue if you have a program that's running a little longer, maybe you should write it in something other than bash. So here's a bunch of useful commands. Curl you probably already know about, maybe JQ too. JQ is great for both parsing JSON and manipulating JSON. grep, filter lines, sed, awk, we went through. Jot generates a sequence, a number sequence. You can do get from 1 to 10 or 1, 3, 5, whatever you need. tr is used for translating one character to another or deleting characters. Xargs is if you have a lot of arguments, then you can tweak them around, so you can just get one command or one argument per command, or 5 arguments per command, whatever. And parallel will let you do the same thing, almost, but in using all your CPUs. WC for word count, counts characters, words, lines. Cut for removing small parts of a line. And if you need get command line, you know that at standard, like in Git, you pass -m, -i, whatever. Git ops is your friend. But I'm more, especially if you're using it in the DevOps pipeline, just pass your arguments as environment variables to the script. So here's another example where we're using curl to get the information from a GitHub repo. And then we're using JQ here to get the tag name out of this, so we get the upstream version. Then we're using, inside our Docker file, we're using AWK to look up the line that has polyfill version as the second, in the second column. And then we print the value that's after that, because that's a version. So now we have the upstream version, the current version, and we compare those, and then we can do create a pull request to fetch more new information, or actually update our code. And there's not really anything new there. So, and finally, or I have maybe one more slide, but if you want to watch files, or if you do something periodically, there's a bunch of ways to do that. You probably use nodemon or something like watch. In this case, I'm using something called enter. So you just pass it a list of files, and it will wait and run this command as soon as one of those commands change. So this is excellent. In this case, I just do echo, but if you want to restart the program, so I would do go run main there or something like that instead. Nodemon does the same thing, but usually for node programs. Watch will run, in this case I give it n, so it will run every 30 seconds. And then it will change, or in this change exit here, it will wait until it has changed. If the output changes, this will exit, and then the script can continue to run. So it's great for if you're doing some form of update and you want to poll the server, you can just start a watch command and wait for the output if you have, say, a version.html or something on your server. And silent just means that I'm not interested in all the craft that the curl passes out. So, when should I not use it? I'd say more than 100 lines. Maybe 100 lines is even too large. If you need more than one file to include, you should probably think twice about using bash. But you can also invoke other stuff from bash. You saw AWK, which is a whole different programming language. You can invoke node if you want to do some JSON manipulation. Then you can just invoke that from bash and do all the complex data structure stuff inside Node or Python or whatever. But then just do the basic command line passing or parsing or execution inside bash. So, and also if you have any structures and stuff like that, it's usually very painful to work with in bash. And here's a book recommendation. This is my favorite book on, among other things, bash. It will go through bash, AWK, sed, VI, find, everything. It's a fantastic book. So I highly recommend this one. And if you have any questions, fire away. And the slides should hopefully be up on this URL, SlideShare. Other than that, I'm done.